Welcome back to the Universe series. As you all know, in our part 2, we have discussed about the stars. In our today's video, we are going to discuss the life cycle of a star. So let's get started.
3, 2, 1.
Do you know stars also live and they also die? In fact, they also leave the remains behind them when they die. In today's video, we are going to discuss an interesting topic of the universe which is known as life cycle of a star. Nebula is often called as beginning star. Stellar nebula is a cloud of dust thrown out by stars after dying. Some nebula are also called as star nurseries. The gases in nebula are mostly hydrogen and helium. Nebulas are present between two solar systems. This space between solar system is known as interstellar space. If nebulas has large amount of dust, it can become a massive star, and if it has less dust and gases, it will become an average star. First, let's talk about average star. An average star is smaller than massive star, but it can has more lifespan and produce more energy than a massive star. When an average star runs out of fuel of hydrogen for nuclear fusion, in this case, the hydrogen atoms combine together to form a helium atom. This fusion creates the energy that star needed to resist the force of gravity, and then the star expands. The average star is now a red giant. When red giant star dies, the heat and pressure from its core ejects the outer layer of the star into the space. This outer layer come to known as planetary nebula because of intense fusion reaction takes place inside a star. Planetary nebula tend to made up of hydrogen gas. When planetary nebula runs the last fuel, it runs out of fuel and the left of the remains the core of the star, which is known as white dwarf. It's the brightest object in the universe. Often the Polaris is also a white dwarf star. Here ends the story of an average star. Then what about the massive star? One as well as the star also runs out of hydrogen, but bit faster. It literally becomes 80 to 40 times bigger than the massive star. After that, the core explodes, and the explosion is called as supernova. Supernova is 100 times dangerous than a nuclear holocaust. Then the supernova will become either a black hole or a neutron star. Neutron stars are formed when a massive star runs out of fuel and collapses. The very central region of a star, the core collapses, crushing together every proton and electron into a neutron. If the core of a collapsing star is between 1 and 3 solar masses, these newly created neutrons can stop to collapse, leaving behind a neutron star. Stars with higher masses will continue to collapse into a stellar mass black holes. The collapse leaves behind mostly dense object known as an object with a mass of a sun squeezed down the size of a city. These stellar remnants measure about 20 kilometers, 1.5 miles across. The sugar cube of a neutron star material would weigh about 1 trillion kilograms or 1 billion tons. On Earth, about as much as one mountain. One star's end is a black hole's beginning. Second, let's talk about a black hole. Most black holes are formed by the remnants of large star that dies in a supernova explosion. If the total mass of the star is large enough, about 3 times mass of the sun, if it can proven theoretically that no force can keep the star from collapsing under the influence of gravity. However, as the star collapses, the strange thing occurs. As the surface of the star nears imaginary surface called event horizon, time of the star slows relative to the time kept by observatives far away. When the surface reaches the event horizon, time stands still and the star can collapse no more. It's now frozen collapsing object. Even bigger black holes can result from stellar collisions. Soon after its launch in December 2004, NASA's Swift telescope observed the powerful fleeting flashes of light known as gamma ray bursts. Chandra and NASA's Hubble Space Telescope later collected data from events afterglow, and together the observations led astronomers to conclude that the powerful explosions can result when a black hole and a neutron star collide, producing another black hole. Although the basic formation process is understood, one perennial mystery in the size of black holes is that they appear to exist on two radically different size scales. One end. There are countless black holes in the remnants of massive stars peppered throughout the universe. These stellar mass black holes are generally 20 to 24 times as massive as Sun. Astronomers spot them when another star draws near enough some of the matter surrounding it snared by black hole's gravity, churning out X-rays in the process. Most stellar black holes, however, are very difficult to detect, judging from the number of stars large enough to produce such black holes. However, are very difficult to detect. So finally, it's the end of our video. In next video, we will see about constellations. If you want to know about constellations, stay tuned and subscribe to our channel. Bye bye.